While there are large amounts of electric vehicle manufacturing factories going up in the US, very many cell manufacturing plants currently being constructed, there still is really not the quantity of primary battery metal manufacturing facilities being constructed. Those vehicle plants and those cell plants are relying almost entirely on foreign-sourced battery metals to make their products. This means that there really isn't a closed loop within the North American market yet. This open loop really leaves domestic companies vulnerable with regards to the security of their supply chain, to the cost of having to source and pay import tariffs on all of those materials, and it really doesn't give them the necessary visibility on the environmental impact of what really happened in the sourcing of those metals.
American Battery Metals is both primary mining company, where we're working to extract lithium and other battery metals, and we've also developed an in-house full recycling train for the recycling of lithium-ion batteries. It really allows us to both add new primary material to the supply loop, and also to take end-of-life and waste material, recycle it, and turn it right back around in that same loop.
So currently there are many companies out there who have laboratory scale efforts for recycled lithium-ion batteries, for the manufacturing of battery metals, but doing work at laboratory scale only goes so far. What the industry is really looking for is someone who can actually make these materials at commercial scale. So for a recycling facility, we have to consider both the large amount of material already in the market with older technologies, plus brand new technologies being made today, plus any changes being made in the future to make each of our recycling facilities future-proof and a wide breadth of type of feedstock that they can take in. One of the big advantages of this design we've come up with is that it has dramatically lower environmental impact compared to other types of lithium manufacturing processes that are proposed. We have far lower consumption of acids and other chemical loadings, far lower generation of waste materials. And during this NEPA review, all that came to the surface, and we were excited to get such a great response in our environmental review.
Pure Lithium is commercializing a breakthrough lithium metal battery technology and manufacturing process that is clean, sustainable, scalable, and cost-effective. Lithium metal is widely acknowledged as the material needed for superior next-generation batteries that are safer and higher energy density. Pure Lithium's novel technology eliminates more than 80% of the current manufacturing costs in lithium metal production, which in turn unlocks widespread adoption of lithium metal batteries that cost less than $50 per kilowatt hour. The United States is home to a diverse range of lithium-bearing deposits, from hard rock spodumene and oil field brines in the southeast to clays, conventional brines, and geothermal brines in the west. Pure Lithium's technology can take that lithium from the ground and put it into a battery right here in the US, leapfrogging the current Asia-dominated supply chain. Pure Lithium's metal electrodes are elementally pure. Our one-step electrodeposition process creates a clean, native interface that's protected from air and moisture, which improves performance and reduces costs. As a woman-owned business, Pure Lithium has embedded working for environmental justice and treating communities as stakeholders into the very fiber of our company. We are uniquely capable of training technicians with high school or technical backgrounds to hold valuable jobs in the battery industry. Pure Lithium's process can be deployed either close to lithium production or in manufacturing hubs. We are an integral part of securing the energy supply chain, and that depends on building the lithium batteries of the future here in the United States.
I'm Bob Mulaney. I'm the CEO of ITAP. The key to the battery industry is extending its life as long as you can and putting them in second life applications to live out their life cycle.
This is Marshall Neipert, Chief Technology Officer of IT Asset Partners. After investing $12 million into R&D, we have successfully built second life solutions for all lithium batteries in the United States. At ITAP, we use the past to power our future. Lithium batteries can last 10 to 20 years depending on how they're used, but most are discarded within 5 to 7 years. These two mugs represent lithium-ion batteries. This mug represents the scrap recycling solution, and this mug represents reuse. This still has value. Now let's look at the scrap recycling solution. Do you see the difference? And if this is LFP, the taxpayer has to pay to get rid of it. Everybody knows the tsunami of EVs is coming to America. The question is, what are we going to do with the batteries? Electronic waste in our landfills is responsible for 70% of the heavy metals leaching into our water table. Only 17% of e-waste is recycled in America today. But what if there was a better answer? What if there was an innovative solution that could benefit everyone? What if we could retain the value of the lithium batteries? Reduce, reuse, recycle. We are all told this as children, but where's the reuse in America? In 2017, ITAP realized that EV batteries would become the largest single volume of low-value hazardous e-waste in the United States. ITAP is actively paying our customers for lithium batteries, including LFP, while processing all EV battery waste domestically and maintaining a zero landfill policy. We are requesting support to expand these second life solutions nationwide and automate the process to create true sustainability for EV battery waste within the United States. Reuse makes things affordable. It provides abundance in a world of scarcity.
All our products are returned here, made here, and moved out into the market as US-made products.
The choice is ours. We can incentivize recyclers to reuse or fund a doomed scrap recycling system.
So the message I have for you, the DOE, is if you want to put the time and effort, we're your partner. We've invested in the technology, we understand it, and we know how to do it safely.
As you decide how to allocate this funding, we hope you consider reuse as the true sustainable solution, turning our country's lemons into lemonade. Thank you for your time.
COP26 aims to reduce global net emissions by 2050. Some of these goals include a speed-up switch to electric vehicles and an encouragement of investment in renewables.
Canada is warming on average twice as quickly as the rest of the world. And in our north, it's 3 times quicker. The science is clear. We must do more and faster.
Electric vehicles are an important part of meeting global goals on climate change due to their high energy conversion efficiency and integrated use of renewable energies.
At the end of the electric vehicle lifetime, typically 8 to 10 years, the battery materials need to be recycled.
The Canadian government has announced a mandatory target for all new light-duty cars and passenger trucks sales to be zero emission by 2035.
At CNEM, we aim to recycle these batteries in greener ways that benefit the environment. Black mass treatment is a difficult task in EV battery recycling. Current recycling approaches include pyrometallurgical processes at high temperatures of 1600 degrees Celsius to melt everything down. The pyrometallurgical process is very energy intensive and only recovers non-ferrous metals of nickel and cobalt while leaving lithium, iron, aluminum, and manganese in the slag waste. The organic electrolyte, anode graphite, as well as polymer separator are all burnt into incredible amounts of CO2 and toxic gases. The hydrometallurgical processes rely on strong acids to dissolve the black mass. The chemicals used in the hydrometallurgical process are not present in the battery active mass. These chemicals will be incinerated and sent into the atmosphere in the form of sulfur dioxide and can also end up in the waste streams.
TNM has developed a green recycling process by using distinctive physiochemical properties of battery active materials to separate the cathode material from the anode material. The process includes advanced classification technologies used for microelectronic material processing. The recycled cathode materials are reconditioned via hydrothermal and plasma processing to restore their stoichiometric and microcrystalline characteristics, which can be reused for EV battery manufacturing. This green process is energy effective and environmentally friendly and is currently patent pending. Our current objective is to run a mini plant to demonstrate the green recycling process towards commercialization.
Battery is becoming the most important technology for this decade. After the recent global political instability, it is evident that energy security is the number one priority of our nation. For Advano, a team of 25, have an experienced management team working along with a strong advisory team. We are in Louisiana State. We're known for hospitality culture, world-class logistics, and amazing chemical engineering talent. We produce one of the most complex and most dangerous materials, and we still ship them across the globe because these are materials that the entire globe uses today. We welcome other companies in this industry to locate here and transfer jobs from oil and gas industry to clean energy, as we all agree that we need to solve the energy security issue, as well as making as many batteries ourselves in this country. Advano is specialty chemical silicon processor, and silicon is becoming the sixth most critical element for the battery industry. We convert metallurgical silicon into battery grade silicon for anode production. We have two materials ready for commercialization. We're addressing the industry's biggest challenge, which is not just performance, but also address other two main issues, which are cost and volume. We use no environmentally damaging specialty chemicals or as raw materials. No sealant gas is used in our process anywhere. We're building our first pilot line in Louisiana. As you all know, Asia dominates the production of battery materials, batteries, all the main components and equipment. And Advano wants to be a significant contributor in making US the leader in the next generation batteries. After getting the formal offtake agreements, we'll launch our commercial plant in 2024. We plan to go 100% solar for our manufacturing and all our operations. Companies like us, as you know, need a lot of support from the government as well. The loan and grant programs are very much needed. And we encourage all other battery companies work alongside of others so that as a team, we can win the commercialization race and have our batteries built here at lowest cost, in highest volumes, with best performance. Thank you.